Hello everyone. This is Dr. Kavitha, Assistant Professor, PG and Research Department of Physics, Seethalakshmi Ramaswamy College, Tiruchirappalli. In this video, I'm going to explain about the construction of character tables. What is a character table? A character table is a two-dimensional chart associated with a point group that contains the irreducible representations of each point group along with their corresponding matrix characters. Using the four important rules of the great orthogonality theorem, the character tables of C2V H2O molecule and C3V ammonia NH3 can be constructed. The rule number one is the total number of symmetry operations is equal to the order of the point group H. This is the C2V point group character table. In this, E is the identity element, C2 and alpha XZ, alpha YZ are called the symmetry operations. So the symmetry operation is equal to 4, which is equal to the order of the group. And gamma 1, gamma 2, and gamma 3 and gamma 4 are called the irreducible representations. The number of irreducible representations is equal to the number of symmetry classes, which is equal to 4. This is the point group. By applying the rule 1 for C3V point group, E is identity element, 2 C3 and 3 alpha V are called the symmetry operations, which is equal to 6. 1 plus 2 plus 3 equal to 6. The order of the group is also 6. As the symmetry operation number is 6, the order of this group is 6. And gamma 1, gamma 2 and gamma 3 are called the irreducible representations. So the rule number 2 of the great orthogonality theorem is the sum of the squares of the dimension ki squared equal to k1 squared plus k2 squared plus k3 squared plus k4 squared, which is equal to the order of the group. Say for example, if I'm substituting k1 and k2 and k3 and k4 as 1, we will get the answer as 4, which is equal to the order of the group. Similarly, for C3V point group, by applying the rule number 2, by substituting the values of K1 as 1, K2 as 1, and K3 as 2, we will get the answer 6. 6 is the order of this point group C3V point group. 6 is the order of C3V point group. By applying rule number 3, the sum of the squares of the characters, that is rows, in any irreducible representation is equal to H, the order of the group. Say for example, for C2V point group, 1 into K1 squared plus 1 into L1 squared plus 1 into M1 squared plus 1 into N1 squared. That is here the product of G into X psi I R squared equal to the order of the group. Here the G represents symmetry operation. Here it is 1 and 1 into K1 squared plus 1 into L1 squared plus 1 into M1 squared plus 1 into N1 squared equal to 4, because 4 is the order of this group. So by substituting the values of L1 as L1, M1 and N1 as 1, 1 and 1, we will get the answer as 4. So this rule number 3 is satisfied. Similarly, for C3V group, by substituting the values of K1 squared, 2 into L1 squared, 3 into M1 squared must be equal to 6. So, by substituting L1 is equal to 1 and M1 equal to 1, this rule is satisfied. Therefore, by substituting the values of L2 as 1, M2 as -1 and N2 as -1, the rule can be satisfied. Similarly, for C3V point group, by substituting L2 equal to 1 and M2 equal to -1, we will get the other characters. Similarly, for C3V point group, 1 into K1 into K2 plus 2 into L1 into L2 plus 3 into M1 into M2 must be equal to 0. Therefore, by substituting L2 equal to 1 and M2 equal to -1, we will get 0 as the answer. So we have constructed the character tables for C2V and C3V point group using the 4 rules of the great orthogonality theorem. Thank you.